Hello, everyone. Myself and the obscenely loud cricket that's in the room next to me. I apologize about that. Welcome you both to Pisa Presents the magnificent mica minerals. Now, micas are one of those minerals that I think get really underestimated. A lot of people have heard of them, but very few people, I think, appreciate them for how incredibly awesome they are. So let's look into a little bit of the awesomeness of these magnificent micas. First of all, they are a mineral family. There's actually several different varieties of micas, not only a few, there's quite a few of them. Now, if you've ever seen the rock granite, take a bow. Okay, close enough. You have seen an example of a rock with micas in it. In this case, mica known as biotite, arguably along with muscovite, probably the two most famous micas they are. A lot of the thin, dark flecks that are sort of rectangular shaped in granite, that is the mica known as biotite. Now, there are several dozen species of these minerals. They're silicates. They have what is called perfect basal cleavage, which is geology speak for a mineral that can break along perfectly even planes, almost like sheets, basically. Sheet is actually a word that is used quite often to describe them. Now, some people have likened them to paper towels. It's an analogy that I've used a lot, even back in the day when I was a geologist. Why it is so pertinent to these and why it is so applicable, we'll get into a little bit better later. Now, this is just an example of what a mica can look up close. Yes, you can famously have these sheets where they just split into perfectly that is in a wonderful, lovely picture right there that illustrates just these wonderful, gorgeous sheets that they can split into, which are, yes, they may be thin, they may be somewhat brittle, but still they can actually be pretty flexible. But then you look at up close is on the left, so basically under a microscope, and then still you look at a specimen like the one on the right, and yes, you can see that the appearance is a bit flaky, but still all the same group of minerals, but still, like any group of minerals, there's a bit of variety in their appearance. Now, the term mica dates to around 1706, but micas themselves have been studied much earlier by name into 1535. They've gone by different names as a group over the years, and they've been used by mankind since really the Paleolithic days for various reasons. Now, overall, that lovely letter salad right there is actually their formula, where X, Y, and Z stands for various elements that can substitute in for that formula. So basically, any mineral species in there can have something approximating that general formula. Now, what do they have in common though? Well, they have a monoclinic crystal system. They are of various colors. They have a hardness of at least 2.5, a specific gravity of at least 2.8. They are phyllosilicate, which is a term that means sheeted silicate minerals. And because of that, they have generally a flaky appearance. So now let's look into the silicate matter, shall we? Well, these micas are basically composed of, not basically, they are composed of what is known as silica tetrahedra. So you have those little red dots, or the silica atoms, and then they are bonded to 4 oxygen altogether, sometimes. Now, with micas, they can take different forms, but sometimes you can have 3 oxygens bonded to a silica, and then instead of the 4th oxygen, you can have aluminum, ferrous iron, magnesium, several other things. Other times, in case of the group of micas called the quote brittle micas, you can have 2 oxygen and then 2 aluminum. And with each tetrahedra sharing 3 potential oxygen atoms, basically, so each tetrahedra shares 3 of these non-silica atoms here, they bond into a sheet. So this individual thing right here is a sheet. It's basically a network of these tetrahedra. So now micas consist of these bonded silica tetrahedra. They can bond into not only tetrahedral but also octahedral sheets. You may see them abbreviated as both T and O in some of the geology literature. Now, octahedral micas are further divided into both dioctahedral or trioctahedral micas, which were ones that have 2 and 3 coordinated cations respectively. Now, dioctahedral minerals commonly have aluminum as the main cation. That is basically the specialized element other than oxygen that bonds in its place. But the trioctahedral minerals often have the ferrous, iron, or magnesium. Brittle micas can really be either dioctahedral or trioctahedral, but still they're considered their own category. So micas can be found all over the world. Not only that, but they're found in every major rock type. They're found in both igneous, sedimentary, and also metamorphic rock. The micas are often found in clays. Their sheeted structure is what allows for water absorption, like our friend the paper towel. So if you can picture a paper towel, if you get a paper towel wet, it will get to the point to where the water just goes through, and sometimes the paper towel just kind of goes into shreds. But if you take a stack of paper towels and get them wet, not only can they absorb more water proportionately, but they're stronger. Still, all the same, once they're soaked, there is no turning back. And that is something that micas do to clays just in spades. So clays and clay soils contain a lot of mica in them. And because of that, clay soils are famous for being able to handle a lot of water up until that point of no return. And then you get that. That's why after a very, very hard rain, if you have a lot of clay soil, you see that water just kind of standing there on the top. Your soil can only take so much water, and it's absorbed a lot already from this heavy rain. It just can't take anymore. So micas are used in, sorry, that one picture I just find funny. Micas are used in a lot of things. It's from paint, cosmetics, various electrical applications, and wiring, automotive, even parts in, say, things like microwaves, ovens, refrigerators. They're very, very good thermal insulators. They're also used in various mechanics for drilling, whether it be oil, natural gas, or other resources. They are found in plastics. They are also found in various insulating substances that you have throughout your home, used in decoration. Like down there in the bottom, there is a photo of mica snow. Sometimes the fake snow that you can buy at a store around the holidays is actually mica. Because it has that flaky appearance, it is also used kind of like back in the day. It gives like a glittery look to things, which is why it's used so much in cosmetics. And then, of course, up at the top, yes, that is a staged photo. That guy is not like lying passed out underneath a sheet of drywall, although God knows all the years that I was a construction inspector, I've seen worse than that. So, yes, micas are also a big component of drywall. Now, some famous micas that we're going to be looking at here. Biotite is a trioctahedral mica, and it's usually very dark. Sometimes I have kids ask me, how do you tell the difference between biotite and muscovite? Well, really, all in all, those are going to be the two most famous micas that you're dealing with. And traditionally, muscovite is lighter colored, biotite is darker colored. Think of the B in biotite. Biotite means, well, B in black. Yes, it's not always black. Here, of course, it's brown, but still, just kind of use that as a little hint. Clintonite is one of the brittle micas. This one I actually like because the individual that these were named in honor of, Henry DeWitt Clinton, a town neighboring where I live in, was also named after Clinton, New Jersey. And there's a famous area there that used to be actually a mineral mine. Several, as a matter of fact. So what makes brittle mica so brittle? Well, if you remember back all that substitution that they had, because of that, they have less silica and less water. There are other things substituting for the silica, which makes them more brittle. Now, this is lepidolite. This is just to show that micas aren't always kind of the dullest dishwater colors right there. This specimen from Brazil is, of course, an absolutely lovely pink color. This is margarite. That's kind of like the pinkish color that's right there. This is a relatively local specimen from Massachusetts. This is our aforementioned friend muscovite. You can really look at sort of the platy appearance of it right there. This specimen is from Brazil. This is phlogopite. It's a trioctahedral mica. Now, this particular mica, although not this specimen, I'd like to clarify, holds the record for the biggest mica specimen ever been found. So there's a mica found of this species in the Lacey Mine, Ontario, that was 33 foot long by 14 foot by 14 foot, and it weighed 360 tons. That is a big honkin' mica crystal. Now, Zinwaldite, this is an absolutely stunning photo. It is not only that, but it's also fluoroapatite with topaz, arnzenwaldite, and quartz is the official title of it. But that's an absolutely stunning specimen, just to give you an idea of also, too, the variety of minerals that micas associate with. Because they're so common and they're such like a universally found mineral, they're associated with, and you can find them with, a lot of other minerals as well. So that is just a quick look-see into the magnificent world of the wondrous micas. So thank you very much, folks, and enjoy your weekend now. Bye!